Welcome back. We have already explored what GenServer is, and in today's video, we are building our first one, our very own customer tracker server. The plan is to track the number of customers entering and leaving the restaurant. We start by creating a new project called Tracker using the Mix command line tool. On the terminal, I will write mix new. The mix new command helps you to create a new project, pass the name of the project, which is called Tracker, and add the soup flag. The soup flag creates our application under a supervision tree. We shall explore later what is a supervision tree. Hit enter and our tracker project is created successfully. Once the project has been created, open your editor and let's add a file where we shall build our customer tracker server. I shall add the file under the lib folder and name it customer tracker server. Inside this file, I'm going to create a module using the def module keyword. The name of our server is customer tracker server, and I shall also pass the use GenServer. By passing use GenServer, it will give us access to the function and the callback that are available within the GenServer module. Before we jump into the code implementation, we need to first plan to understand which GenServer functions and callbacks do we need to use. First, what is the initial state of the restaurant? Let's say our restaurant opens at 7 a.m. with no customers. We can have the initial state with customers as 0 and time as 7 a.m. We shall use a map structure to represent the state. At 8 a.m., the restaurant begins receiving customers, possibly 2 or more. The state should be updated to reflect these new changes. Let's take note of the new state. So we can have the customers in the new state as 2 and time is 8 a.m. Our restaurant also has a supervisor who will be inquiring for the exact number of customers in order to assign waiters to different tables appropriately. Finally, we have supervisor inquiry and we need to provide the current number of customers. Now that we have our plan in place, what are the GenServer callbacks that we need? To make this happen, we shall use 3 GenServer callbacks. The first one is the init callback to initialize the GenServer process with the initial state. When customers arrive into the restaurant, we need to update the state. With that, we shall use the handlecast callback. When the supervisor asks how many customers are there, we need to retrieve the current number of customers. The callback that will be responsible for retrieving the current state is the handle callback. Our server has the responsibility of updating the state when new customers arrive and also retrieving the current state. Now, who sends requests to the server? That means we also need to implement the client side to fulfill the client-server interaction. We shall use 3 GenServer functions on the client side. Note that on the server side, we are using the GenServer callbacks. On the client side, we are using the GenServer functions. The first function is the start link. This function will start the GenServer process and also links it to the current process. When customers arrive into the restaurant, the client needs to send requests to the server to add the number of customers to the state. In this case, the cast function will be used to send an asynchronous request to the server. This means that we shall not expect any response from the server. When the supervisor asks for the number of customers, the client needs to send request to the server to retrieve the current state. In this case, we shall use the call function to send synchronous requests to the server, meaning we shall expect the server to respond with the current information from the state. We are now heading somewhere. We have a clear trajectory of the function that needs to be implemented on the client side and the callbacks that needs to be implemented on the server side. It's also important to note when implementing these functions and callbacks provided by the GenServer, you need to understand the required arguments and the expected return value. Let's start the interactive shell to verify that our code actually compiles before we start implementing the server and the client APIs. To open the interactive shell, run ix-smix command. We are receiving a warning that the init callback of RT1 required by the behavior GenServer is not implemented in our customer tracker server module. For now, they have injected a default implementation, and this is how their default implementation looks like. We are receiving this warning because we passed the use GenServer in our customer tracker server module. Use GenServer will automatically inject the behavior GenServer. In Elixir, behaviors are like contracts. They ensure that the set of required functions are implemented, and if the defined functions are passed as required by the behavior. That's why earlier I had mentioned that you need to take note of the required arguments and return value expected when you use the GenServer functions and the callbacks. Behaviors are important when modules share a public API. In our case, GenServer serves as the public API we are using. We can now get started with implementing the server API. In the server API, we needed only 3 callback functions, that is the init of RT1 to initiate the process and the initial state. We also need the handle casts of RT2 to update the state, and we need the handle call of RT3 to retrieve the state. Let's start with the init callback. So before we define this callback, let's see what the init callback requires as the argument and what it returns as the expected value. I will head over to the GenServer documentation. Under the GenServer module, we have the callback section. Open the callback section and go straight to the init callback. You can see that the init takes in one argument. This argument can be any term, then returns and a tuple of an atom under state. It can also return a tuple of an atom of state, timeout, or an atom hibernate, or even a tuple of an atom continue and the continue argument. It can also return an atom ignore and also a tuple of an atom stop and a reason. The reason can be any term in Elixir. In our case, we are going to return a tuple of an atom under state. Let's go ahead to define it. This is the init callback. Takes in an argument, then we return a tuple of an atom and the state. We are passing the state as a map structure, and this is how the initial state looks like. For now, let me just pass it as the state. If you're wondering why I passed it as the state, remember when we received a warning? Let me go to this warning. In the warning, they mentioned you can copy the implementation above or define your own that converts the argument given to GenServer start link of RT3 to server state. That means when you call GenServer start link function, it's going to invoke the init callback to initialize the process. This init takes in an argument that is passed to the startLink function. That means, in our case, when we are calling the startLink function, we are going to pass it an argument which will be our initial state. With a tuple of an atom under state return value, our process will be initialized successfully, and also the initial state will be set. Next is the handle cast callback. Let's see what the GenServer docs has to say about it. The handle cast takes in 2 arguments. The first argument is the request, and the second argument is the state. The request can be any term, and the state also can be any term. Then it returns a tuple of an atom no reply and the new state, or a tuple of an atom no reply, new state, timeout, or an atom hibernate, or a tuple of an atom continue and a continue argument. Also, you can return a tuple of an atom stop, reason, which can be any term, and a new state. In our case, we need to only return a tuple of an atom no reply and a new state. This return value will continue the loop with the new state, and that is all we need to do. Let's define the handle cast. Takes in the request and the state and returns, and we are returning no reply and the new state. Handle cast is the one responsible for updating the state when customers arrive or leave the restaurant. How will the handle cast know that it needs to add customers when they arrive or remove customers from the state when they leave the restaurant? We need to be specific with the request that handle cast needs to handle. If the customers are arriving, we need to tell it that we need to tell the handle cast that it's handling the request of adding customers to the state. So here I'll replace the request with a more specific message, which is add customers. I'm passing it as a tuple, add customers, but it can be any term. You can also pass it as a string the way you wish it. Then it also needs to know that when customers leave the restaurant, it needs to update the state by removing the customers who have left. I'll copy this and paste it, then replace the add customers with remove customers. That way it will know which request to handle. Now, how can it know the number of customers that it needs to add to the state or remove from the state? This information needs to come with the request that it's receiving. So passing it as a standalone atom is not flexible for us, because we also need to know the number of customers that we are adding or removing. Instead of passing it as an atom, I'll pass our request as a tuple. Remember, request can be any term. You can also pass it as a list or a map, the way you wish it to retrieve the information easily. In my case, I'll pass it as a tuple. The first item in the tuple will be add customers. Then the second item in the tuple will be number of customers. The same thing will be done on the other handle cast. I'll just copy and cut this. Now we have the information that we will need to update the state. If you're wondering if it's possible to call a callback, a GenServer callback more than once, the answer is yes. You can call it as long as you pattern match it with how you want to handle it, depending on how you want to handle it. Now we have the number of customers and we need to update it. This is add customer. That means our new state is of a map structure. We need to update the information in the state with the number of customers that we need to add. I need to update the state. I'll remove this. Have our state, and in the state I'm updating the customers. The number of customers is an integer value, therefore I'll do state.customers to retrieve the initial number of the customer number and add that number to the new number of customers that we have. We have updated the customers in the state. We also need to update the time so that we know that at this time we had this number of customers. We have time. With time, I will pass it as a, let me see if I can use time. Which function of time can I use? We can use time UTC now. We shall do the same in the remove customers. I can copy this the way it is and replace the new state with that. But now remember, with the remove customers request, we need to subtract it instead of adding. The final callback we are implementing is the handle call. Let's see how it works. Handle call takes in 3 arguments. The first argument is the request, the second argument is the from, and the third argument is the state. The request can be any term. The from refers to the reference of the process, and the state can also be any term. We already know that our state is a map structure. Then the return value can be a tuple of an atom reply, a reply, and a new state. It can also be a tuple of an atom reply, new state, timeout, or an atom hibernate, or a tuple of an atom continue and a continue argument. You can also return a tuple of an atom no reply and a new state. And also you can have a tuple of an atom no reply, new state, timeout, or an atom hibernate, or a tuple of an atom continue and a continue argument. You can also return a tuple of an atom stop, reason, reply, and a new state, or a tuple of an atom stop, reason, and the new state. We need to retrieve information when we send requests that will be handled by the handle call. Therefore, our return value needs to return for us a reply. In this case, we shall use the first return value, which is a tuple of an atom reply and the new state. Let's define the handle call. Takes in the request, the from. I'll put an underscore to from, and this is because we are not going to use the from argument and the state. Our return value will be the reply, a tuple of an atom reply, and the new state. But we are not updating the state when sending requests to be handled by the handle call. Instead of the new state, we'll just return the state as it is. What is the request in this case? We want to get the number of customers when supervisor inquires or asks for the customer number. Therefore, our request needs to be specific. We can call it get customer number. Then it needs to send a reply to the caller. And our reply, they mention if the reply can be any term. Yeah, the reply can be any term. We can return the reply as a string, just the way we had mentioned here. We have current customer number, so we need to pass it here. This means I want to interpolate the value that I want to retrieve from the state. Interpolating is like concatenating, so I want to concatenate the string, the current customer string, with the integer value that I'm retrieving from the state. And this is how I can interpolate that value. We have state.customers, current customers number, and add is. Then we can also pass the time. The same thing I will have to interpolate state the time. Therefore, when we want to get customer number, we shall have this information. The current customer number is, and also the time will be given. The server API is completed. We can now move to the client API. Usually it's recommended to define the server API and the client API in different modules. But in this case, I am demonstrating and the application is still small. I will have to define the client API in this module. For the client API, we are using 3 functions. That is the startlink function. We have the startlink, which will start the GenServer process. We have the cast function, which is the one that will be used to send requests to the server to update the state with the current number of customers. Then we have the call function, which will be used to send requests to the server to retrieve the current number of customers. We shall start with the startlink function. Head into the GenServer docs to confirm what the function takes in. So we are no longer using the callbacks. The startlink function takes in 3 arguments. That is the module, the initial argument of the second argument in the startlink. Then we have options, which defaults to an empty list if it's not passed. The first argument is the module. This we can pass as the module that we are currently in, that is the customer tracker server module. Then the initial argument can be any term, and the options needs to be passed as a list if we want to pass the options. First, we'll start by defining a custom function, which will be used to invoke the GenServer startlink. I'll define a public custom function. I'll just call it startlink. Pass the argument as default. This is the custom function. Inside this custom function, we are going to invoke the GenServer startlink function, and it takes in the module name. The module name we can pass as the customer tracker module. You can pass this or copy the exact name as it is. Then the second argument is the initial argument. The second argument, I'll pass it as the argument that we shall pass when we call our custom start link. Just pass it as default. Remember that this default argument is the one that will be passed to the init callback once we start our server. Therefore, our argument here will be a map structure. If it's not passed, we can pass a default argument. I would prefer we pass a default argument if we don't want to pass anything, and the default argument will be our initial state. I'll just say customer. I'll pass a map of customer 0 and time as time.utc now. That's it for start link. Next is the cast function. Let's see how it works. The cast takes in two arguments, that is the server and the request. It needs to know the server in which the request needs to be sent. Here, the server can be passed as the PID. The PID refers to the process identification, or we can also pass the name of the registered process. When we are calling the start link, we are not registering our process. That means when we call GenServer cast function, we shall pass the PID instead. Let's define a custom function which we are going to invoke. In this, we can say the cast adds customer and sends request to add and sends request to remove the customers. In this case, I can call it as add customer. This is the custom function. Add customer takes in the server. It will text the server. We shall pass the PID. Then takes in the request. Remember the request that we passed as we are adding customer, which is the tuple. The handle cast expects the request as a tuple of atom of add customers and the number of customers. I've just remembered that this is the function that we need to invoke. I'll just pass this as request because we are calling it. Then this function needs to invoke the GenServer cast for our request to be sent to the server. GenServer cast takes in two arguments, that is the PID and the request. We also need to define another custom function called remove customer. We don't have to have two functions which are calling GenServer cast. We can only have one. We can name this add or remove customer. Add or remove customer. The function will call GenServer cast, give it the PID and the request that it needs to send to the server. The final function that we need to invoke is the GenServer call. It takes in three arguments. The first argument is the server, which I mentioned can be the registered name of the server or the PID. The second argument is the request that needs to be handled by the server. And the third argument is the timeout, which defaults to 5000 milliseconds or 5 seconds. The timeout specifies the time that the call function can wait for the reply. If within the 5 seconds, which is the default value, the call function does not receive a reply, it will time out and also cause the caller process to exit. Let's define a custom function called getCustomerNumber. GetCustomerNumber, which will invoke the GenServer call function. The GenServer call expects three arguments, which we have seen is the server and the request. The timeout, we shall use the default 5 seconds. When we call getCustomerNumber, we need to pass it the PID and also we need to pass it the request. GenServer call function will take the PID that we pass that the server needs to handle. Congratulations for the job well done. We have just completed implementing our tracker server. We are now ready to interact with our customer tracker server. Let's test our code in the interactive shell. We already opened the interactive shell. If you closed yours, just call the ix-smix command again. we made changes to our server module, therefore we need to recompile. Notice that the warning has disappeared, and that is because we added the init callback. We now need to spin up our customer tracker server by calling the start link, which will start the GenServer process. When we call the start link function, it's going to return a tuple of an atom and a PID. That indicates that our process has been initiated successfully. When calling the startLink function, we shall pattern match with a tuple of an atom and a PID. Then call the customer tracker server and pass it the startLink function. If we don't pass any argument to the startLink, the argument will default to what we passed. You can see we have a tuple of an atom and a PID. This suggests that our GenServer process has been started successfully. What is the current number of customers? We can easily check that by calling get customer number. Customer tracker, we call the get customer number, which we need to pass the PID that we pattern matched when starting the GenServer. Then the request. So the request that is expected, it's an atom get customer number. This will retrieve the current number of customers in the state. And we are having an error. Our GenServer has terminated and it's complaining of the key customers not found in the map that we passed. We have a key error, which is the key customers is missing in the map that we passed. This is customers and this is customer. We missed to pass S in our default value that we passed when defining the startLink function. So we can easily rectify that, then recompile our changes. Now notice that which PID were we using. The GenServer PID is 152. This is the process identification of our GenServer. Then you can also see the client PID is this one, which we were told is alive. The client PID in this case is the caller process, which is the interactive shell, which we are using to invoke the functions that we need to send requests to the server. Our interactive shell is acting as the client. Let's confirm if the PID we are told is matching. This PID, at this point we are told get customer, the state is this, the client PID is alive. This was the client PID at that time. Then when everything just blowed up, the client PID also exited. Here we're told the shell process exited, and this was the previous PID of the interactive shell. What we have here, let me just close this, then call self again. What you have here is the current PID. So when our GenServer process is terminating, the caller process is also affected and exits and restarted again. We have rectified the customer keys that we were passing in the start link. Now recompile the changes, and we need again to start the GenServer process because the previous one was terminated. We have a new PID, that means another GenServer process has been started. Then we can now call the get customer number, give it the PID and the request. And here it is. We have our current number. We are told the current customer number is 0 and the time, this is the time. 2 customers has just entered the restaurant. We need to update the state. The state needs to reflect the customers that have just entered the restaurant. Invoke the add or remove customer, pass it the PID and the request that it needs to send to the server to update the state. Our handle cast expects a tuple of an atom, add customers, and the number of customers that it needs to add. 2 customers just entered the restaurant. Remember, with the GenServer cast function, we don't expect a reply because it's sending asynchronous requests to the server. Regardless if the request is successful or not, it will always return an atom. To know if the state was updated, we need to call get customer number, and the current customer number is 2 and also the time is updated. Then one of the customer is done with their meal. Now they are leaving. We need to call add or remove customer again Pass it remove customer, replace the add customer with remove, then remove one. We have sent request to the server to remove that one customer. Now get the current customer number. How cool does it sound knowing that you can build a stateful process that you can interact with? Our customer tracker server is working as expected. What would you like to build with the GenServer tool? Drop your ideas in the comment section. Follow for more Elixir tutorials. Next, I'll be talking about concurrency in GenServer.